This is topic 15, video E. Let's practice number 4. So the problem tells us that the chemist produced 3 compounds that had the same formula C6H5X, where X can either stand for chlorine, bromine, or NO. So we know we're going to be finding X, and let's write down the 3 candidates' molar masses so that it's easier for us determining which one it is at the end. So chlorine is 35.453 grams per mole, bromine is 79.904 grams per mole, and NO is 30.007 grams per mole. Okay, next thing we do is set up the chemical equation as best as we know it from the information given. So C6H5X, and it being a combustion reaction, of course an O2 is involved, and being a hydrocarbon, it gives us a carbon dioxide and H2O. Their masses are given, and let's write those masses down so that we can utilize them as best as we can. 37 grams of CO2 and 2.62 grams of H2O. Now, remembering the law of conservation of mass, we can know that however much carbon was produced in the CO2 and however much hydrogen was produced in the H2O came from C6H5 because no new mass can be created. So let's find out how much carbon and how much hydrogen resides in each one of them by using percent composition. So we do that by dividing the molar mass of carbon with the entire molar mass of CO2, and then multiplying that with the grams of CO2 given, and we take a similar approach for our H2O. So that's 2.016 because there are 2 molecules of H2O available, plus 16 multiplied by the mass of hydrogen given. So that gives us 4.195 grams of C and 0.293 grams of hydrogen. So that's how much grams of carbon was available in C6H5X, and that's how much grams of hydrogen was available in C6H5X. So if we combine them, we can find the total mass that we began with of C6H5 and use a comparative approach to finding X. So let's add them up together and see what we obtain for the mass of C6H5. Okay, so we get 4.88 grams of C6H5. And another component that we can find of C6H5, just by knowing that it's C6H5, is its molar mass. And that we do by adding its atomic mass. So it's 12.001 because that's carbon's molar mass, and there are 6 carbons added with 5 times 5, the molar mass of hydrogen, and that gives us 77.106 grams per mole of C6H5. So we have one component of C6H5 and we have a second component. Now, X. We can find the mass of X given in the entire compound, and that we can do by subtracting the mass, the entire mass of the sample of C6H5, which is 6.23 grams, and subtract the mass of C6H5 that we figured out using percent composition. And that gives us 1.742 grams of X. Now we have 2 components of C6H5 and 1 component of X. So that is like a good call to algebra because we can use proportions, and the rules of proportion is just simple that we need to have at least 2 components of one sector and just 1 component of the other sector. And if we know 3 of the 4 components, we can find the 4th one by using cross multiplication. So let's get to that. So we have 4.88 grams of C6H5, and that's equal to the let me write that all over again just for the sake of clarity. 88 grams is equal to 1.742 grams of X. And the second information that we know about C6H5 is its molar mass, which is 77.106 grams per mole. Now, the moles of X, of course, we don't know. That's what we're looking for in the first place. I mean, the molar mass of X, we don't know, and that's what we're looking for in the first place. So we do a little bit of cross multiplication and obtain our result. Okay, so cross multiplication gave us 29.93 grams per mole of MWX. So that's the X that they're referring to. Now let's match it to the chart that we have over here. Is it chlorine? It's a little further from chlorine, so no. It's way further from bromine as well. So NO is the closest it gets to. So the formula that we have is C6H5NO.